Welcome to Nerdy Lecture Series on Thermodynamics. Through this lecture series, you are going to learn how to derive series of very important relations in thermodynamics. Before going into the lecture, let us familiarize with this mnemonic. Scientists have purified gases that are very unique. The first letters of each word reflects the standard notations for thermodynamic variables. S. Entropy. H. Enthalpy. P. Pressure. G. Gibbs free energy. T. Temperature. A. Helmholtz free energy. V. Volume. And U. Internal energy. Now, to begin with, let's draw a square and sequentially arrange the thermodynamic variables on the square like this. Place the arrows as shown. This is very important because the pointer of the arrow indicates minus sign while the other end indicates plus sign. We can derive three sets of thermodynamic relationships using this. First, relations connecting midpoint to corners. Second, relations connecting corner to corner. Third, relations connecting midpoint to midpoint. First sets of equations connecting corners to midpoint are called fundamental thermodynamic relationship. First of all, we are going to see how H is related to corner points S and P. Here, dH equals plus T ds plus V dP. We have the adjacent variables ds and dP. Also, we have T and V lying on the end of the arrow as constants. More importantly, you are going to add the signs of the variable in both segments. So here dH equals T ds plus V dP. As none of the variables S and P has arrow pointer, both segments of the equation receives positive sign. Similarly, you can derive dG equals plus V dP minus S dt. Here, second term has minus sign as T has the arrow pointer or minus sign. We can go on deriving an expression for dA, which is dA equals minus S dt minus P dV. As expected, both terms have minus sign as T and V are lying on arrow pointers. Now, du equals plus T ds minus P dv. As S is positive, first term is positive and second term gets minus sign as V is on arrow pointer. In summary, in this video we have learned 4 very useful thermodynamic relationships through a mnemonic. In the next lecture, you are going to learn how to derive very useful sets of relationships called Maxwell's relations using the same mnemonic.